Hello everyone, welcome to NPTEL classes. Today I am here to solve chemistry class 12th NCERT problem 2.18. Let me read the problem. Calculate the mass of non-volatile solute. Molar mass 40 gram per mole, which should be dissolved in 114 gram octane to reduce its vapor pressure to 80%. This problem is based on the fact that when a solid non-volatile solute is added to pure liquid volatile solvent, it results in lowering of vapor pressure of solution. Vapor pressure of solution containing non-volatile solute is less than pure solvent, and difference between vapor pressure of pure solvent and solution containing non-volatile solute is called lowering of vapor pressure, and it depends on mole fraction of non-volatile solute. Greater the mole fraction of non-volatile solute, greater will be lowering of vapor pressure. But this problem has also, after reading the problem, I got to know that problem has a purpose. What is purpose? Purpose is that we want to decrease vapor pressure of octane to 80% of its vapor pressure in pure state. We want to decrease vapor pressure of octane to its 80%. And for that, we have to add non-volatile solute whose molar mass is 40 gram per mole. Now we have to calculate how much mass of non-volatile solute we have to add in 114 gram of octane so that its vapor pressure is reduced to 80%. Idea is that lowering of vapor pressure and mole fraction of non-volatile solute is related by this equation: P01 minus P solution divided by P01 is equal to mole fraction of non-volatile solute X2. P01 is vapor pressure of pure liquid solvent. P solution is vapor pressure of solution containing non-volatile solute. P01 I already told it is vapor pressure of pure solvent. X2 is mole fraction of non-volatile solute present in solution. Non-volatile solute I will represent by 2. Non-volatile solute I will represent by 2, and volatile solvent that is octane, volatile solvent octane I will represent by 1. Now what mass of non-volatile solute is to be dissolved in 114 gram of octane, that I need to calculate. W2 I need to calculate. Its molar mass is however given. Molar mass of non-volatile solute is given and is equal to 40. Mass of solvent octane is also given 114. Molar mass of octane is also known to me, and molar mass of octane is 114 as well, 114 grams. I need to calculate mass of non-volatile solute that is to be dissolved in 114 grams of octane. Molar mass of non-volatile solute is given 40. Molar mass of octane I know 114. Now I need to calculate how much mass of non-volatile solute is to be dissolved in 114 grams of octane so as to reduce its vapor pressure by 80%. So vapor pressure of question says that vapor pressure of solution is 80%, is only 80%, is lower than pure solvent. And how much is only 80% of pure solvent, pure octane, that is P01. These are given parameters in the problem, and these are unknown parameters in the problem. This is unknown parameter which I need to calculate, and rest are known parameters. Now, lowering of vapor pressure. Lowering of vapor pressure. Lowering of vapor pressure is represented by P01. It is equal to difference between vapor pressure of pure solvent and solution. It is colligative property. It is colligative property. It is colligative property. And any colligative property is strictly valid for dilute solution. Strictly valid for dilute solution which contains relatively negligible amount of solute or relatively less amount of solute, is strictly valid for dilute solution. So this equation P01 minus P solution divided by P01 is equal to mole fraction of non-volatile solute. It is also valid for dilute solution. So here I will use the approximation that solution is dilute such that this equation is valid for this solution of octane containing non-volatile solute. Now P01 is vapor pressure of pure octane. P solution, it is 80% of vapor pressure of pure octane, and 80% will become 80 divided by 100 into P01, and it will become equal to 0.8 P01. So vapor pressure of solution is reduced to 0.8 P01 divided by P01 is equal to, mole fraction is the ratio of number of moles of solute N2 and number of moles of solvent and solute N1 plus N2. But solution is dilute. Number of moles of solute are negligible in comparison to number of moles of solvent. In denominator I will neglect N2 in comparison to N1. So I need to write N2 divided by N1. And now N2, number of moles of solute, will be equal to W2 divided by M2, and N1 will be equal to W1 divided by M1. It will come like this. Now in this equation in this equation I will take P01 I will take common from in the numerator. P01 I will take common. P01 and P01 will get cancelled. I will get 1 minus 0.8 is equal to W2 is given. No, W2 I need to calculate. M1 is given molar mass of octane, that is 114. M2 is given 40 and W1 is also given 114. 114 and 114 will get cancelled. Here it will come 0.2 W2. So W2 will be equal to 0.2 multiplied by 40 and W2 will come equal to 8 grams. So answer to this problem is 8 grams. Let me recall. In the problem it was given that we are adding non-volatile solute of molar mass 40 to 114 grams of octane so as to reduce vapor pressure of solution to 80% only. Molar mass of octane is known to me 114. Octane is C8H18. Its molar mass is 114. I need to calculate how much mass of non-volatile solute I need to dissolve in. I need to add to 114 grams of octane so as to reduce its vapor pressure to 80% only. From the question I got to know that problem is based on concept of addition of non-volatile solute to pure solvent, and addition of non-volatile solute to pure solvent always results in lowering in vapor pressure of solution. Vapor pressure of solution containing non-volatile solute is always less than pure solvent. This is called a lowering of vapor pressure, and when related with pure solvent it is called a relative lowering of vapor pressure. Relative lowering of vapor pressure is related with mole fraction of non-volatile solute. From this equation, greater the mole fraction of non-volatile solute, greater is relative lowering of vapor pressure. Next, I said that relative lowering of vapor pressure is a colligative property. It is strictly valid for dilute solution. So, in order for this equation to be valid, here I need to use the approximation that solution is dilute, and it made my calculation simple because in the numerator I could easily neglect N2 in comparison to N1 so that calculation part will become easy. And after calculation I got weight of non-volatile solute that is dissolved in 114 grams, that is added to 114 grams of octane so as to reduce its vapor pressure to 80% is 8 grams. And here in this equation I substituted that I had to substitute only one parameter on left side, that is vapor pressure of solution, and in the question it is given that vapor pressure of solution is 80% of pure solvent and 80% of P01 will become 0.8 P01. Then P01 I took common in the numerator. P01 got cancelled. 1 minus 0.8 is equal to 0.2. Here on RHS side 114 got cancelled. 14 to 0.2 came equal to 8 grams. Class 12 students, this is what I had for you today. See you day after tomorrow with one new problem. Till then, take good care of yourself, as tomorrow is turn of class 11 students. Allah Hafiz.